The next talk is titled as Achieving the Web Isolation Nirvana. How far along are we? The presenters are Pedro Fortuna and Jasvir Nagra. He also goes by Jazz. Both are representing JScrambler. Thank you. Over to you.
Hello, everyone. It's great to be back to a real live stage, and it's of great joy to be sharing it with my dear friend Jasvir. So our talk today will be about web isolation. It resulted from a retrospective thought exercise on the last 20+ years of web isolation.
So what are we looking for? We're looking for a series of principles or reasons that underlie what we have done as a community right, what we've done wrong, and what kinds of lessons we can learn from them. And that's what's going to drive the structure of our talk today.
But before we get too far, let's introduce ourselves. So my name is Pedro Fortuna. I'm a co-founder and CTO of JScrambler. And I've basically been working with security for as long as I can remember.
I guess that brings that to me. My name is Jasvir Nagra. Most people call me Jazz. That's what you should call me too. And I guess I've been working in security for as long as Pedro can remember.
So we want to start with a little story.
Pedro, there's like 30 minutes remaining before happy hour. And you want to do, like, we're the only people that stand between all of these people and a well-end drink. You want to do story time?
Yeah, I mean, we are on a movie theater, so I thought that storytelling is actually the perfect spot to be doing it.
Let's do it.
So we want to tell you a little story about the ship, which most of you have heard about. You want to guess what ship this is? Yep. The Titanic. Yep. So basically, it was built in Belfast in Northern Ireland in their famous shipyard, which I was actually lucky enough to visit some years ago. And we want to talk about how it was built. So many people don't know this, but the Titanic back then, it was bleeding edge in many ways, all right? So for instance, the bottom of the ship was split into 16 watertight compartments. And it could withstand up to 2 adjacent compartments completely flooded without compromising the ship. But depending on the specific location of the hit, it could go as high as 4 adjacent compartments completely flooded. Okay? So this technique is to ensure the stability of the ship despite the presence of damage. So that's like the worst case scenario they could think of back then, and that's why the Titanic was deemed to be unsinkable. But we all know how this story ended. When the Titanic hit the iceberg, the 6 forward compartments were compromised. And even though it didn't end well, the compartmentation was actually a great idea. So, and it's still used in ship design to this day. Basically, the basic idea is that damage to a single section of the ship won't compromise the other sections. Okay? But the problem with the Titanic was that its implementation was flawed. But we'll tell you more about that later.
Wait, seriously, you're going to leave this cliffhanger there? Fine. Why don't you tell us a little bit about web isolation, a completely different topic, seemingly.
Right, sure. So the first attempt to do web isolation inside the browser was introduced by the same origin policy to restrict how two cross-origin documents can interact with each other. But restrict how if we can embed a third-party script being loaded directly from a third-party server, and it will actually have the same amount of privilege than any other script, any first-party script running on that page. So it turns out that embedding is permitted as per the same origin policy. What is restricted is writing to or reading raw data from cross-origin documents. So the reality is that the same origin policy is complex, has lots of exceptions, and to this day, most developers don't fully understand it, which is frequently the source of security issues. A couple of years later, we got iframes, okay, with which we can isolate two documents in different, two scripts into different cross-origin documents. But soon enough, people started poking holes through it, trying and finding ways to have those cross-origin documents communicating between each other. And basically, only 13 years later, we threw the towel and finally introduced or made it official by introducing the web messaging API, with which two cross-origin documents can communicate voluntarily. But that didn't fix all the problems. Iframes had too much power. For instance, an iframe document can navigate away the top window, among other things. And basically, it took a while, but 13 years later, we got Iframe Sandboxing. With sandboxing, we can greatly reduce the amount of privilege that iframe document has. But at the same time, we got a bunch of different attributes that, with which we can relax some of these restrictions back. Roughly at the same time, we got Content Security Policy version 1, with which you can set a domain-based allow listing, which was later found to be completely broken. Plus, it's hard to manage. Later versions fixed it, but they are not straightforward to set up. But the main critique on CSP is its lack of granularity. I mean, with CSP, you can either fully allow a script into the page and allow it to do whatever it wants, or completely block that script. Similarly, you can fully allow a domain to be contacted or fully block that domain. So it has no granularity at all and ends up not working because of that. So the main problem with this isolation and defense mechanisms is that people keep fighting them, keep trying to open holes to relax them into getting them to work for their applications. JSON-P and cores are good examples of that. Maybe if they were more flexible and granular, people wouldn't find the need to try to open holes on them.
Can you go back a slide?
Yep.
I've been talking to some people over lunch. You really think that that small JSON-P hole represents the real size of JSON-P?
Well, I accept your critique, but I think JSON-P is long gone, so I prefer to reserve the bigger hole for the CSP strict.
We're going to edit these slides after this talk.
Okay, that's fair. So here you can see a timeline of these features. You will notice a huge gap between 97 and 2009. So we really have to wonder what the browser people were doing during this period. You want to comment on that?
As a browser person, I'm embarrassed by that 10 years. All right. So Pedro's described a whole bunch of browser primitives that have existed that we have used for isolation. Some of these properties work really well, some of them less well. But what is interesting, the question that is interesting to me is, can we use the browser primitives that browsers provide to build an isolation mechanism that is solid? I believe that the answer is yes. And you don't need to believe me. We, the community, has built all kinds of interesting isolation mechanisms based on the primitives that browsers provide to build a wide variety of interesting isolation mechanisms that I'm going to go over. All of these essentially boil down to one of two different mechanisms. On the one hand, you have transformation, where you are changing the source code of third parties or first parties. On the other hand, you have virtualization, where you are changing the environment that the code that you're executing runs in. And essentially, those are the only two real mechanisms that we have available to us. I have plotted 3 different projects that I am familiar with that do these. There's a vast variety of other projects that also do this kind of thing. There's Google Kaha, way off on the corner there, which does virtualization to remove the dangerous to make the APIs that are called less dangerous. It also uses transformation to simply extract and throw away the dangerous parts of of a third-party piece of code. There's a project called JSReg, which some of you may be familiar with, which uses a lighter weight transformation, uses regular expressions to remove the known bad parts and throw those away. And then we have JScrambler's web page integrity, which Pedro, I'm sure, can speak a lot more authoritatively about, which uses mostly virtualization, but also browser primitives to not just mitigate how bad some third-party code can be, but also uses browser primitives to monitor what kinds of DOM mutations are occurring. And essentially, all sandboxing projects use some combination of virtualization and transformation in order to achieve the security properties that they are shooting for. But by a long shot, this is my most favorite transformation, a program transformation for security. It might not look like much, but it is actually the basis for almost every language-based sandboxing mechanism ever executed. What does this mean? Sorry, Pedro. What do you have? You have a series of functions. Alert, functions that you are calling. What are these? You can think of them as system calls in the browser. So these are functions that are provided by the browser that you are calling. You also have these other properties. You have strings and you have arrays, which are native types provided by the browser. And you also have functions that you yourself have written. Here's the deep piece of insight. If instead of allowing the third-party code to use whatever the browser provides, you instead allow the caller of this third-party function to provide what functions are called, what system calls are called, what native types are called. What you get is the ability to control how much power a third-party piece of function gets to have. If you take every arbitrary piece of code and you turn it into a closed function where every piece of code is controlled by the caller, you get a kind of sandboxing which is extremely powerful. Not only that, of course you can do this with JavaScript. Can you do this with HTML and CSS as well? And the answer is yes. In fact, it's even easier to do it with HTML. It's even easier to do it with CSS. Why? Because CSS and HTML are less expressive than JavaScript. So take, for example, the code on the on your right, where a piece of code, a piece of styles sheet was able to change arbitrary B tags to have them have the color blue. By prepending .gadget123, what have you achieved? You have made it such that the number of HTML elements that are affected by this particular CSS rule has been limited to those that are the children of classes that have gadget123 as a class. You have limited the sections of code on your page that some particular third-party CSS can affect. Similarly, with HTML, you are able to subset the HTML so that only some small part of your HTML can be affected by third-party code. So that's tool number one in your security toolbox. What is the second one? The second one is virtualization. Now, I call it virtualization. It's really just polyfills, and you all know what polyfills are, right? What are polyfills? Polyfills are where you have some browser that's not able to provide all of the functionality that you need. What do? You end up writing something which plugs that gap. It emulates the missing piece of functionality. All that virtualization does is essentially the same thing, but it also allows you to plug in the same kinds of functions in the cases where the functionality was provided originally. Here's what I mean. So let's say that you have the need to provide date to some third-party function. In this particular case, you don't care. Maybe you don't care that this third-party function can do some kind of cache timing attacks. You trust that this third-party code cannot do this. And what will you do? You'll provide an identity version of date. You provide the original date function to this third-party code. In another case, you want to be like,
I think the browser just crashed. Oh, shit.
This would be an excellent time to make fun of some browser, right?
Don't do this at home.
All right. I was genuinely about to make fun of a browser. I'm not going to do that now. Wait, I'm still going to do that. OK, so ActiveX, for those of you young enough to remember, used to be part of a browser that we're very happily gotten rid of, mostly, that provided too much power. And if you provided ActiveX access to some third-party code, it would be able to do much more than you were wanting to do. But what you might want to be able to do is allow some third party to have XHR access, but you don't want to be able to allow it to XHR to some arbitrary place. So what do? You use virtualization to provide an attenuated version of XHR, an XHR that's able to do all of the things that XHR can do, but only to the origins you control, or maybe XHR via some particular proxy. And now, all of a sudden, you've largely limited the amount of access that this XHR has. How did you do that? You provided an attenuated version, a new version of XHR, polyfill version of XHR that is only able to do a subset of things that XHR can do. And this is a very powerful thing because let's say you happen to have a browser that I was about to make fun of that did not provide you XHR, but it provided you with a much bigger ability. It provided you with ActiveX, much bigger. But what you were able to do is provided an attenuated version, a smaller version that used ActiveX but emulated what XHR did. Right? Like, so you can provide attenuated versions of document, you can provide attenuated versions of location. What does attenuated mean in this case? It means that you've largely limited what access this third-party code has access to, which means that the attack surface that you are providing to any particular given third-party service is much smaller. Am I going in the wrong direction? The third thing, that's the second control. The third control that I am providing. What do you want to have? Look, every isolation mechanism that one has holes in it. we all know this to be true. In fact, this conference is an example, is evidence that every isolation mechanism, every sandboxing mechanism that we have has holes in it. Sooner or later, the cleverness of attackers, like the people in this room, the stupidity of the sandboxing people, like the people on the stage, is such that sooner or later it's going to break. It is going to break. That's not what the important part is. What is important is that when it breaks, we know that it has broken, and we know the ways in which it has broken, and we can do something about it. What do we need for that? What we need is two things. We need to be able to know what is happening out in the wild on our web pages, and then we need a closed feedback loop such that when it happens, we are able to do something about it. Now, one of the things that you can use is virtualization. Virtualization means that every time you're using an API, not only does it do what it says on the tin, what it says it's going to do, it can also do some additional action. Like send a message back to us to say, hey, in addition to sending an XHR, which we weren't expecting, this piece of code did this extra thing. If you want a simpler example of this, CSP URI reports are an example. It doesn't use virtualization, but it gives you visibility into what is happening that is resulting in vulnerabilities on your web page being taken advantage of by attackers, right? You get reports on how these vulnerabilities are being taken advantage of. In order to do this, what do you need? You need collectors which collect messages, events from what is happening in the wild. You need analyzers that collate all of this information into coherent reports. And then what you need further is visualizers and decoders that summarize and visualize and give you some action that you can take as a result of seeing what is happening in the wild. The thing that I want you to take away from this talk is the principles that underlie all of these different things. If you think about what is the message of the theme of this particular B-Sides, it is what is it that it takes for us to get off the ground? And for us to get off the ground, instead of having a large number of ad hoc responses to individual attacks, what we need is general principles. And I'm going to describe 3 general principles that I feel underlie the idea that we want, which gives us web isolation. Principle number 1, compartment size. The size of the units of isolation is very important. You can imagine having the entire origin, or you can have a domain. You can have a web page. You can have an individual script. You can have an individual API. You can have a tiny little action. And each one of these gives you finer and finer granular control over what third parties are able to do on your websites. Now, the advantage is the finer grained control you have, the more control you have over what amount of damage your third party can do on you. There's a very favorite phrase that I use every time somebody says, do you trust me or do you trust the script? Instead, I reframe that question as, what is the extent to which you are vulnerable? And the smaller the granularity, the smaller the extent to which you are vulnerable to a particular script or to a particular function or to a particular action. On the other hand, what you have is the finer grained your level of granularity is, the harder it is to set up. Like the more configuration it takes, the more you have to think about how much do I want to make myself vulnerable to this script or to this script or to this script? And unless you have some mechanism, some tooling that gives you automated control over the decisions that you have to take, you are overwhelmed by the decisions that you are needing to make. Size matters, and the smaller is better. The second thing is isolation material. Now, the stronger our isolation mechanism is, the better off we are. The problem is that the mechanisms that we use for isolation today were built for a web that we have long stopped using to develop. Developers develop in a very different way. Pedro talked about CSP and he talked about iframes. But in each one of these cases, because the way in which we develop web applications, we don't develop web applications where it's individual pages, right? We develop web applications that are single-page apps. We develop web applications very differently from when these security mechanisms were developed. What do developers do when they face impedance on getting things done? What they do is come with workarounds. They drill holes into the isolation mechanisms that browsers provide. And that's fantastic. They're getting their work done. The problem is, from a security point of view, every hole that they drill makes it harder for the materials to provide the isolation. If you have a ship, what you need is something that is firm. Each of the compartments need solid foundations. And essentially, by working against the developers' mechanisms for development, we make it harder for developers to get their things done. And they drill holes and weaken the materials that we use for isolation. Which brings me to the third point, which is visibility and user-friendliness. Do I say this? I say this, right? Did you know that developers are people too? Developers are people too, and they need user-friendliness on the developer side, right? Anytime that we have APIs for security that make developers' jobs harder, what they do is come up with mechanisms to work around what it is that we are doing to save them, to protect them. The other thing is visibility. Sooner or later, each one of these mechanisms fail. And what we need is visibility when these mechanisms are failing. If you had a ship, let's say, you would need an outer hull and an inner hull, and every time the outer hull is breached, you want to know about it. Whenever the inner hull is breached, you want to know about it. Why? Not because it gives you somebody to blame, but it gives you the opportunity to work out how to respond in a way that lets you fix it. Complexity is the other part of this. There are a number of things that developers need to keep in mind. Keeps growing. It's very, very hard. I walked around the vendor floor today, and I feel like I have a large amount of expertise in the security field. I've been a member of the security community for a long while, and there's large numbers of things that I don't even understand. And I worry about developers having to face a similar kind of complexity. What we need is something that aligns sufficiently well that developers understand what security mechanisms they're employing and where the failure modes of those are. I think that this brings us back to our cliffhanger, Pedro. What do you think?
Yeah. So we promised to tell you exactly why the implementation of the Titanic was flawed. Basically, because the compartments were still too big, and definitely the materials were not iceberg ready, so it would need stronger materials. The damage model, obviously, was incomplete or incorrect, which translating to our context means that the threat model was wrong. And last but not least, lack of visibility. I mean, if someone had spotted the iceberg in time, they wouldn't even have to test the remaining safety features. So definitely visibility and analytics, which is an interpretation of what we see, are essential for a good defense. And now we are presenting some demos. So we'll be using the same scenario across 4 demos, which is a mock-up online banking login page that has one third party, a chatbot. And in some of the runs, this chatbot will be replaced by a malicious version, which will try to capture the login credentials and exfiltrate them. At the bottom of the page, you'll see some controls that are used to basically to configure, to reload the page with different demo settings. So let's start with the baseline. So here is the page. And right now, we don't have any defense, any isolation mechanism. So this is on purpose to see what happens when isolation is lacking. So this is a very simple website. It mostly has first-party code loaded from virtualbank.com. And it has one third party loaded from chatbot.com. So you're already seeing the third party. This is the non-malicious version. It's very simple script. It doesn't do a lot because it's a mock-up script, all right? So the important thing is to understand that it's being loaded from the third party. Now that third party can very easily be compromised. And it has a direct way to load arbitrary code into every user session of this website, all right? So next, we'll show you precisely that. So I'll skip the waiting part just to keep this moving. And we'll check the box of the compromised third party and reload the page. And now you're seeing the malicious version. Let me stop here. So as per the same origin policy, this script is embedded, which means that it has full access to the page, including that login form. All right? So at any given moment, it can access the form, collect the data there, and exfiltrate it. In fact, the code that we're seeing, that code is setting an onSubmit event handler. So it's overriding the event handler that was there before. And when the form is submitted, it will collect, it will do what we sometimes call form jacking. It will collect all the values of every field and will XHR that to a domain controlled by the attacker, which usually we call drop server. In this case, malicious-api.jscramble.com.
This compromise script is our iceberg then?
It is. So let me get back to where we were. All right. So next, what we will do, we'll show you what happens when we type the credentials, which will trigger that malicious code. Okay, so I'm typing my username and password, submitting the form, all right? And basically that malicious code is, after doing what it does, it will call the original event handler. So from a user perspective, nothing will seem strange. This is the drop server UI. Let me refresh it to see from the server, from the attacking server, what was successfully exfiltrated. There you go. All right? So now, in this case, the problem is obvious, is lack of isolation. So the next thing that we can do is just move the third party to an iframe, to a cross-origin iframe, and leverage the same origin policy. Obviously, that basically forces that script to be adapted, in order to work. But we'll just show you the malicious version of that run. All right? So this is the iframe third party. So we'll just enable the iframe third party, compromise third party, and reload the page. So immediately what you see in there, maybe you cannot read it, but it's a console error. Basically it resulted from the fact that the same malicious script is now not being able to access the form, hence the error. Okay? So it was, we were able to mitigate the problem, but obviously being a cross-origin iframed, the problem is gone. There's no way that iframe can access that form. But in order for the original code, the non-malicious version to work, we now have to ask the vendor to work from a cross-origin iframe, which will basically require that vendor to change how it works. Also, we need to change our page because we need now to move this to iframe. And let's not forget, because this example is very simple, we only have one third party, but the average page has tens of different third parties. So the overall accumulated work that it requires in order to follow this approach can be quite significant.
I mean, not only that, each one of these iframes have to be communicated asynchronously, right?
Right.
So you have to refactor all of the code and then now communicate asynchronously with this iframes.
Which can create problems because before they were communicating synchronously, right?
And you know, async code is much harder to create, but also harder to debug.
Right, and now you have to set this protocol with the third party because you can only use the web messaging API. So the next one uses Google Caja. Just, why don't you do this one?
Yeah. So what do you see here? It's a very similar case to the previous one where you're trying to protect yourself by isolating your code with some code that is isolated. Here, what am I looking at? Here we've injected Caja. Actually, it's secure ECMAScript or SES, which is a grandchild of Caja, let's say. What does it do? It injects itself into the page, and then it sets up a situation where it controls what APIs are callable. If you remember what I described earlier, we can decide and whitelist exactly which APIs are necessary for this function to execute. In this particular case, append child and create element are the only things that are necessary. And so those are the ones we whitelist. And we say, yeah, go ahead, do whatever you want, compromised script. All that we're going to allow you to do is call create element and append child. And then Pedro goes ahead and logs in. Pedro can log in from a distance. He types in his password, and now the compromise script is trying to reach in and grab the password, but it cannot because in order to grab the password, it needs to do what? It needs to grab .value from the password field, an API that is not whitelisted. And so when Pedro logs in, if he logs in correctly, I get nervous every time I see this drop server because it looks like it still has a compromised script, but this is the earlier password. This is no new password was leaked. Pedro's password remains safe. What is the difference between the iframe version and the Caja version? It is that refactoring was still required. The code still needed to be changed, but at least it did not need to be asynchronous anymore. Caja allows you, the sandboxing mechanism allows you to rewrite your scripts so that they are synchronously accessible as they were before. And yeah, that's an improvement, right? Like, if any of you have written async code, and I suspect everybody in this room has written async code, if you've written async code correctly, I would like to hire you. But most of us are lying when we say we can write async code correctly. So what this sandboxing mechanism gives us is, yes, we still have to do refactoring, but at least we don't need to suddenly deal with asynchronous code because chaining all of asynchronous code is very hard. If only there were a different mechanism that would prevent us from having to do that.
Yeah.
How about it? Did I set you up right?
Completely. Totally. So to address these caveats, we have been working on a solution called Web Page Integrity, which is basically a sandboxing solution that can be seamlessly integrated into any website by adding a JavaScript agent. And that agent carries a rules engine, which is very granular. And with it, you can specifically say what you should enable at any level of granularity. Or what you want to block, all right? So here you are seeing the dashboard of the latest threats detected, which right now is completely wiped clean. And now what we're going to do is reload the page with that agent together with the compromised third party. And the first thing that I will notice, let me just wait and you will actually see it on the dashboard. So the first thing that we have here is indication that something is interfering with the onSubmit event handler of a form. So we can see in a lot of detail what form was affected, and specifically what is the new event handler that was set in that, to that form. So we can see this code, we can recognize this code. It was the same code that I've shown you before. And right now we are only in visibility mode, so we're not blocking anything. Because this is a demo and it's more like it's easier to talk about things when we're just showing we're not blocking. And here you can see the script that initiated the event, the action, and the specific function that triggered it. So next, let's see what else we can see. Let's log in again and see the malicious code running and what you'll be able to see in the dashboard. So obviously the password will be captured because we're not blocking anything. That's fine for a demo. Here you can see that the exfiltration was detected. And the types of details that we're able to show are like the specific method, XHR, the endpoint, malicious-api.jsgrammar.com, and the specific fields that were basically exfiltrated. And again, you can see the script that initiated the action and the specific function. All right? So obviously, on that attacker-controlled interface, we'll be able to see that password. All right, so now that we understand what's going on, we can start mitigating it. So like I said, we have a rules engine, so we have to write rules. We're not writing rules from scratch here because we have a couple of templates, so, and that's basically faster. Okay, so. Okay, let me stop here. So this first rule, so before explaining the rule, basically let me explain the anatomy of a rule. So we have 4 sections, the which pages in which you basically set the scope of the rule. Is it running for the whole website or just like a section or a specific page? Then you have the which resources with which you can match the initiator scripts, if any, or you don't care, any script will do. And then you have what specific action you want to match. In this case, we're matching any network request sent to malicious-api.jsgrammar.com. And finally, you have the actions, which for this rule, you have the alert and block. You could just alert or block. In this case, we're doing both. So what we need to do now is just enable this rule and commit the configuration and wait a few seconds, after which every user session will actually start being like enforcing this new rule. All right? So let me fast forward this. Okay. We're still waiting for that configuration to be deployed. Then reload the page and see what happens. So remember, what we are doing is we're blocking communications with that domain. So we're not doing anything regarding like the onSubmit event handler rewrite. So that will still happen. But what we will see is whether or not we manage to block that exfiltration. So again, this is the same as the first one we saw. Okay, naturally we're not blocking it. And now we'll sign in to see if we manage to block it. Okay, let me just make it faster. All right, so you can see blocked prefix on the same alert. So it has, so we can still see the attempts, but we have confirmation that it was successfully blocked. All right? So we can actually do better. What we can do is also prevent that on-submit event handler rewrite from happening. So in order to do that, we'll use a second rule, which will basically block any behavior change that targets a form in that page. All right? So it's actually broader than what we needed, but it's all right because it will be easier to maintain, actually. So we'll just enable this rule and commit it, and then reload the page. Okay? And see what happens. So we don't even have to fill in that form, so because that action takes place like immediately. So here you go. All right, so blocked. So again, we can see that attempt, but it was blocked. Now, with this type of approach, you have almost...
Wait. Let me just summarize my mad scientist friend here.
Okay, all right.
So what you did was you had a vulnerable script that was stealing passwords. You dropped a script that you were now able to configure using a UI. And what you got from it was visibility that passwords were leaking. You got visibility on what compromised script was leaking this password. So you could see what was happening. And then you were able to block the compromised password from leaking without making any changes to the original code. And then you were able to even block the mutation of the event handler by the compromised script. Am I getting that right?
Yes.
Okay.
But I want to stress that even though it sounded like to be very reactive, so first need to learn what's happening in order to fix it, the approach actually allows you to be very preventive. For instance, think about a form. You can set an allow list of scripts that should have access to that form. And automatically, every other script is blocked. So you don't have to learn what domains you need to block, what scripts you need to block. It's done, right? And the other thing I want to stress is that here you control the size of the boxes. So you can have boxes of any size without having to re-engineer the application. So we're getting to the end of the talk. It's now time to address the challenges ahead. But before we do that, we must first talk about what we have been doing wrong. So in regards to isolation inside the browser, things have been slow and erratic. And I think the main reason is that there was never one feature whose purpose was to provide full isolation inside the browser. So things have been more about stitching together different isolation mechanisms and try to cover as much ground as possible. This is both error-prone and complex. So naturally, it leaves holes, it leaves blind spots. Beyond the browser, there have been some attempts to provide holistic web isolation. One example was Google Caja, but sadly, it was discontinued. The other more recent attempt was web page integrity that we just showed you. So, what we were shooting for in this talk is to give you a set of principles that should be guiding this critical feature, which is isolation, in order to build web browsers that provide developers with the primitive tools that they need in order to build secure web applications. I think that the three principles that we went over, and I hope I managed to convince you at least part of this, is the granularity of the size of the components that you are using is very critical. At the function or API levels, as long as you have a service or a mechanism that allows you to automatically configure
web applications, you have the ability to control the size of scripts. Stronger isolation foundations, using the browser in order to enforce the isolation mechanism is very important. Providing visibility and user-friendliness is super important because developers are people too, and visibility is super important so that when failures occur, we are able to respond to them. One quick example of something that is being baked into browsers today is Shadow Realms. This is a proposal where the API of an isolation mechanism is controlled by the developer. The API looks very much like an eval. It's really a safe eval where the function is called based inside of a context that the caller controls. It has a stronger isolation foundation. Why? Because the browser enforces it rather than a series of ad hoc mechanisms that are necessary. Why is it user-friendly? Well, developers are already familiar with eval. We all know what eval means. All that we're doing is controlling what context that eval is executing in. It's understandable to developers. It's simple to understand. It is not a series of corner cases. It is just eval in a context. Now, in the case of Shadow Realms, it's missing visibility, unlike, let's say, web page integrity. But the way to think about things like Shadow Realms is not as a full-blown product, but as a mechanism that browsers are providing that allows products to be built on top of it that have these set of properties. To come back to the beginning of this talk, how far along are we? Well, we've made a huge amount of progress over the last 10, 15, 20 years. Projects this size take a large amount of effort, particularly when the way in which we develop is changing. But great projects, big projects require effort and time, and mechanisms like web page integrity, like Shadow Realms, and all of the other things that we are building with the community, with you and I, and all of the security community together, can allow isolation as a mechanism to build the future of web security tools. One of the jokes that Pedro and I had as we were going through this set of slides is, in order to make a ship unsinkable, the only way is to give it wings. I did not realize how appropriate that was until I heard this morning's keynote, and prior to the keynote, I did not even realize that the theme of today's, of this conference is what? It is to get us off the ground. In order to get us off the ground, what we need is to give our web applications, our ship, wings. And I think that that's something that isolation gives us. Take care. Thank you.